Okay guys, here is the first video for our Unit 7 review packet, which is all about right triangles. I'm not going to go through every problem, but I'll at least try to get you started on sections and things like that. So number 1 asks you to solve for x. The real thing we have to do is figure out what method to use. Well, we know we can only use the Pythagorean theorem when we have all three sides, or at least in other words, we have two and we're solving for a third, but we're solving for an angle. It can't be 30, 60, 90 triangle because we don't know what these are. And it can't be a 45, 45, 90 triangle because we don't know what these are. That leaves, so that's when we circle our angle, we label our side. So here's O, here's A. So we're going to use tangent. So I'll let you, actually no, we'll still do this one together. So that's going to be tangent of x equals 8 over 7.8. Remember, the way we undo tangent, because we want to get to the x inside the parentheses, is by doing tan inverse to both sides. Okay. Well, the tan inverse and the tan, they undo each other, just like multiplication and division undo each other. So I'm left with x equals tan minus 1 of 8 over 7.8. And when you type this into your calculator, remember, when we're doing that, we have to do second, and then the tangent button, that gives me that inverse, so tan inverse of 8 over 7.8. That gives me 45.7. So that's my answer. Okay. Number 2 is also a trig problem. I'll let you guys do this one by yourself. Let's look at number 3. Select the measures that could be the 3 side lengths of a right triangle. Well, my key word here is right triangle. In order to be a right triangle, a squared plus b squared has to equal c squared. Well, we're just going to start plugging things in. You could try 17 squared plus 20 squared equals 21 squared. Remember, they have some options down here. You'll notice that this doesn't work. You can try 17 squared plus 21 squared equals 29 squared. You'll notice that one doesn't work. If we do 20 squared plus 21 squared equals 29 squared, we get 400 plus 441 equals 841. Well, look at that. We have 841 equals 841. That means it's a right triangle. So these are going to be my 3 side lengths. We have them in the right place. This would be a drag and drop problem on the SOL. 29 has to be the hypotenuse, and then 20 and 21 have to be the legs. These can go, these can be switched, but 29 has to be on the side by itself. Okay, 4 is another trig problem, so I'm just going to skip that for now, but this is a trig problem because notice we have an angle that's not 30, 60, or 45, so we have to use trig. Let's do number 5. When I printed this, I accidentally, this picture got shifted on top of the answer, so we're just going to do it like a free response problem. But it says an equilateral triangle is folded in half, and they show you this new picture. What is the height of the equilateral triangle? Well, wait a minute. We know this is 60, because that shows us that. If this is 90, that means this has to be 30 because they have to add up to 180. 30 plus 60 is 90. 90 plus 90 is 180. The whole bottom was 14, so if we fold it in half, we're going to get 7. Well, we know if we want to go from the small side to the medium side, we have to multiply by root 3. So we're going to get 7 times root 3. That's the value of x. Number 6, it says, which of the following can represent the measures of the sides of a right triangle? Well, again, if I see this word right triangle and I want to see if it's the sides, I'm going to check if a squared plus b squared equals c squared, and all these options will. So I'll let you guys test that by yourself. Here's the next page. It says find the value of each trig, and then here is your keyword ratio. I don't want to solve for x or solve for anything. I just want to figure out what the trig ratio is. In other words, what's my relationship that I'm being asked for? Well, it says it wants cosine of d. So here's d. Here's my opposite side, my adjacent side, and my hypotenuse. The cosine relationship is a over h, so 3 over 5. All I'm asking for is the trig ratio, the fraction. Ratio and fraction mean the same thing. Or in other words, well, actually, for the most part, they're the same. But we're not solving. I just want to know that the cosine relationship for d is 3/5. So let's do another one. Let's try tangent of e. Here's e. Here's the opposite side for e. Here's the adjacent side for e. Here's the hypotenuse for e. So tangent of e is O over A, so 3 over 4. Okay. Notice for this whole section below, it says solve using trig. So we already know that we're going to have to use SOHCAHTOA to solve. Okay. Why don't we do, let's do number 15 together. So here's my angle. So I always start by circling my angle. Then I'm going to label my sides. Okay, so here's O. Oop, nope, that's not O, sorry. This is O. Opposite is always the one that's opposite the angle. Adjacent means next to. H stands for hypotenuse. Then we're going to use SOHCAHTOA. So step 3 says use SOHCAHTOA. So these are just my steps for solving trig problems. So I have A and I have H. That tells me to use cosine, C-A-H. So I have cosine of my angle equals A over H. I find these the hardest to solve, and there's some shortcuts, but I'm going to do it the long way to make sure you get it right. If I want to get x by itself, the first thing I need to do is get x out of the denominator. I need it in the numerator. So I'm going to multiply by x on both sides. Those x's are to undo each other, dividing and then multiplying by the same thing. They undo each other. So now I have x times cosine of 70 equals 15. Well, I still want x by itself. Right now it's multiplied by cosine of 70, so to undo multiplying by cosine of 70, I'm going to divide both sides by cosine of 70. When I do that, I now have x equals 15 over cosine of 70, and I can type that into my calculator. So I'll do that really fast. Okay, and that's going to give me an x value of approximately 43.857. Now, for those of you in my classroom, I've asked you to round to the thousands place, but for some of you in other classes, your teacher's given you different rounding instructions, and make sure you follow what they are asking you to do. Okay, this is all trig, so it's all circle your angle, label your sides, and then using SOHCAHTOA to solve. Okay, so let's go on to the next page. Okay. This section is on the Pythagorean theorem. The Pythagorean theorem, look, I'm telling you to use the Pythagorean theorem, is a squared plus b squared equals c squared. So I'm going to jump straight to number 20 because 19 is pretty easy. Remember, the hypotenuse has to go on the side by itself. So I'm going to have root 5 squared plus x squared equals root 14 squared. Well, squaring and square rooting undo each other. So root 5 times root 5, that's what this means, is just 5. X squared is x squared. This says root 14 times root 14, or you could square the square root of 14. The squaring and the square rooting undo each other. I'm going to subtract 5 on both sides. And I get x squared equals 9, and the square root of 9 is 3. Okay. Well, 21's a little trickier. So here's my hypotenuse, right? So root 6 plus x squared, and then I'm going to get the hypotenuse by itself. Well, root 6 squared is just 6. Here's where it gets tricky, and you have two options for how to deal with this. The first is that you can type it in your calculator. I'll do that in a second. The second is to recognize that this is really asking you to do 2 root 2 times 2 root 2. That's what it means. Well, 2 times 2, we multiply the outsides together, and we multiply the insides together. So the outsides get to 4, multiply the insides, you get 4. Well, wait a minute. Root 4 is the same thing as 2. 4 times 2 is 8. So I end up with x squared equals 2, which means x equals root 2, or approximately 1.414, I believe. Yep. So this is the first way to do it. The other option is when you get to the 2 root 2 squared, in your calculator, you're going to put a parentheses, and then you're going to do 2 root 2. Now on the old ones, notice I have to close the parentheses for that radical, and then I close it for the whole thing. If you have a newer calculator, that 2 is going to go under the radical and you just arrow out. But you need to make sure you have a parenthesis in the front and something that closes it, because we want to square this whole thing. Notice what happens if I don't square the whole thing. So that says 2 root 2 and then squared. I get something different, and that's because the calculator thinks I'm saying 2 times and then only square the square root of 2. That's what it's assuming I mean when I do that. So we need to make sure we're doing parentheses, 2 root 2, and then square the whole thing. That'll get you to 8. So just be really careful when you use your calculator. Okay. This is determine if the triangle is acute, obtuse, or right. The big thing you really need to know is if a squared plus b squared equals c squared, then it's right. If c squared is too small, if this number is the smaller one, then it's going to be acute. If c squared is too big, then it'll be obtuse. Okay, here's this bottom section. I should have put on here solve for x and y using special right triangles. You'll notice it says to leave your answers in simplest radical form. That means your answers can't be like a decimal that you round. It needs to have a radical in it. Well, it won't always have a radical, but if there is one, you need to leave it. So for instance, let's do number 25 first. In my class, I know some teachers use the ratios. What I do is I say, okay, these are the two legs of a 45, 45, 90 triangle. Because that's 45, we know that's 45, and these are going to be exactly the same. This thing right here is going to be my hypotenuse. If I want to get from my leg to my hypotenuse, I multiply by root 2. If I want to get back to my leg, I divide by root 2. So notice I have the hypotenuse. If I want to find the length of my leg, go this way, I have to divide by root 2. Dividing by something is the same as putting it in the denominator, okay? So now I have 2 root 2 divided by root 2. And you'll notice when I simplify that, all I have left is the 2. So that means my x has a value of 2. And since my legs are the same, my y also has a value of 2. Okay? I'll let you guys do this one by yourself. The key is on Blackboard, okay? Here's a 30, 60, 90 triangle. And for 30, 60, 90, I say, okay, wait a minute. Here's my small side. This is my medium side. This is my long side. Because remember, the longest side is always across from the largest angle. The smallest side is always across or opposite from the smallest angle. So that's how it which. So the 30 goes with the small, the 60 goes with the medium, the 90 goes with the large. Here's our rule for this one. You can only work, like the small is what gets you to everything. So to get to medium, I multiply by root 2. To get back, I divide by root 3, divide by root 3. To go from small to large, I multiply by 2. To go backwards, I divide by 2. So I have started with my medium side. So I'm here. The only option I have right now is to solve for the small side. And the way I solve for the small side, oh, I can't talk, sorry guys. I solve for the small side is by dividing by root 3. So my medium side was 5 root 3. I have to divide by root 3. So I'm left with just 5. So that's the value of my small side, y. Okay. Now I'm at my small side. I need to solve for my large side, and the way I get from small to large is by multiplying by 2. So if I multiply my short side, which had a value of 5, by 2, I get my long side has a value of 10. Okay, so I'm going to end this first video. I'm going to do another video in a second, but I hope that was a good review. There's a key with all the answers, but no work on Blackboard as well. So for the ones I didn't do, you can still check your answers.